In exercise 1, we need to find the value of inductance, capacitance per phase per kilometer in the line. DAB, DBC, and DCA. So these three is actually the parameters already given in the lab sheet. Next is GMD, which is geometric mean distance. So this is the formula that I'll be using. On the 7th line, we have GMRL inch. So this is geometric mean radius value of inductance in inches. But the question need in foot. So on the next line, we have the formula in foot. So this is the formula for the inductance. Then it will display the value of inductance here. So next is this is for conductor. Okay, so enter the value of conductor, which is already I have in the lab sheet. So this is formula will be used. So GMRC, geometric mean radius value for the capacitance, and then enter the value of capacitance, which is already given in the lab sheet, and it will display the value of capacitance. So this is the coding that we'll be using in the exercise 1. So we'll try to run the program. So this is the first one. The AB value is 35 as in the lab sheet. Also the DBC 35, and this is 70. So this GMRL value is 0.5238, and it will display our value of inductance. Next is our diameter of the conductor is 1.345. So we'll get the value of our capacitance. Thank you.
Assalamualaikum, my name is Muhammad Zuhairi bin Zulkifli. So today I will present exercise 2, which is I need to find the value of inductance and capacitance per phase per kilometer for this transmission line in MATLAB. Okay, firstly, we write the program 2 in the MATLAB. So this is the coding. Okay, for the first row, we need to insert the value of D12, and then for DBC, we put the value of D23, and DCA, we put the value of D. So this is the fourth row, the equation of GMD, and then we insert the value of diameter of conductor, and then the radius is diameter over 2. And next, we insert the value of bundle spacing, and then we insert the value of GMR. So this is the equation of GMRL and GMRC. And then we display the value of inductor. So this is the equation of inductor per phase. And lastly, we display the value of capacitor, and this is the equation of the capacitor. So to get the output, firstly we click the run, and then we put the value of DAB, which is 25. Also this DBC is 35, and then the value of DCA is 70, and the diameter of connector is 0.977, and the bundle spacing is 18, and lastly the value of GMR is 0.3924, and we click enter. So this is the value of inductor and capacitor. We can compare to the lab. So this is the value of inductor and capacitor.
My name is not AMIRA NATASHA ZAIROL. My metric number is CE 2054, and I will explain about exercise 3. The coding given will first is we will run the coding, and in the command window we show the enter row vector S11, S22, and S33. This thing will get from the question S11 from here, and S22 from here, and S33 from here. And after that, enter row vector H2, H12, and H23. We'll get from here the distance between line this and line this, and H23 get from here. For bundle spacing, we get from here. We get from the equation is the bundle spacing is 18 inch. And for the conductor diameter is 1.427. While the lastly is geometry mean radius, we get from equation, we get from GMR. After that, the coding will run and get the answer, this answer, but the answer MATLAB is not same with the manual solution, but it quite similar with the manual solution. As you can see, this is 0.49 and this is 0.44.
Assalamualaikum and hi, my name is Izzah Hazirah binti HEDZIR and my metric number is CE190220. So regarding from the task that already been explained by my friend AMIRA for the exercise 3, so we already do this exercise together, and exercise 3 is to determine transmission line parameters. The result were obtained for short, medium and long line models. This was the method that provides reliable result for the long transmission line. For transmission line, it would be best as it used the measurement to calculate the capacitance as well. The exercise was aimed at determining whether it would be possible to determine the parameters of a line from measured data. Thus, the positive sequence line parameters L and C per phase per kilometer of a three-phase single and double circuit transmission line for different conductor arrangement will determine and verify with MATLAB software, and the result is already be obtained by us, and it was success. So we can relate from this task for lab 2 that power system and computation of line parameters have a comparison on the performance of power system and coordination analysis, design power system equipment and develop control algorithm. The performance of a transmission line depends on the parameter of the line. Transmission line has 4 electrical parameters where it's resistance, inductance, capacitance and conductance. The inductance and capacitance are due to the effect of magnetic and electric field around the conductor. So the aim of the experiment is to determine the positive sequence line parameters L and C regarding from the explanation from my friends before. The power transmission line is one of the major components of an electric power system. Its major function is to transport electrical energy with minimal losses. And that's it from me. Thank you.